Hello and welcome to another session where we are going to talk about a simple application of a modular arithmetic, specifically shift ciphers. Now this is coincidentally the first step to a very large and very important topic in terms of cryptography, information security, and all related things, where the idea is that you have a message that you're trying to send to someone else, but you don't want it to be intercepted and discovered. Maybe it's secret plans, maybe it's sensitive information, and you don't want the interceptor to be able to read and understand your message. So you have to jumble it up somehow and then send it and establish a rule for how it was jumbled up so that the actual receiver also knows the rule, can reverse that jumbling and read your message. But if you don't know the rule, then you intercept jumbled letters, for example, symbols, and you don't know what it means because you don't know how to decipher it. So that is the idea. And I'm sure among others in history, Julius Caesar used this to great effect by taking the alphabet, and he wanted to send a message to his commanders, to his troops, without anyone else discovering it. So as the messenger carries the message to the front line or wherever the troops are stationed, they could be captured and their message could be discovered, but that person can't read it. So what he did to encrypt his original message was he shifted all the letters by 3 positions. So an A would become a D, and then when the person would see the message, the correct person would know it was shifted by 3, and they would simply shift it back. Now we can be a little bit fancier, sort of setting you up in case you want to explore this topic further by making it a little bit more mathematical and therefore flexible to allow for complexity down the line. We're not necessarily going to look at that in this video, but it's sort of the foundation that you can build on. So we're going to undo these arrows quickly to still look at Caesar's system, but make it a little bit more, I guess, official and fancy. So we're going to assign numbers 0 to 25 to each letter in our alphabet. And then when we want to take, let's suppose, we would call that a plain text letter, the original letter, and we want to encode it, encrypt it by shifting it to a D, we would really take the value of that letter and add 3. So the 3 is what we call the key. The key is 3 in Caesar's system. But the reason why we number it from 0 on is because what happens when we get to the end here? Sure, if we get to W, 22 plus 3 is still 25. But if we look at X need to encrypt to the letter A. And if we take 23 and add 3, let's take 23, we add 3, but we do it modulo 26, then the answer will be 26, which is equivalent to 0. And so we have to have this identity for addition, this 0, as the place that we start, so that everything loops correctly. So that is the idea. So now if we go over here, don't look at everything all at once, just over here first. mathematically, we can say, okay, we take a letter X and our key K, and the encryption rule is then take the letter value, the value of that letter, add the key mod 26 so that everything loops correctly. And if the correct deceiver knows if the correct receiver knows our key that we used, they can reverse that by simply taking, for example, the value of D. That's what they're going to get. And they know, well, we added 3, so they're going to have to subtract 3, that same key. But an interceptor won't know the key that we used, and so they won't as easily be able to figure out the message. Now, I know this is a very simple first step, and you only have so many possible keys that you could test and figure out the message as the interceptor, but it's the foundation, and you can mathematically make this much more complicated where it becomes really difficult. And by the time the interceptor has figured out by trial and error and testing different keys, your troops have already invaded, everything's done, and the message is completely useless. So let's do a couple of encryption examples and a couple of decryption examples, at least the first ones. So if we have the letter O and we want to encrypt it with the key 5, we would have to go and look, okay, well, what is the value of O? O is over here, right? O is over here. Let's clear up some of these things. We don't want all of this nonsense to distract us. Back, back, back. O is over here, and it has a value of 14. So we would then take our encryption of the value 14, and that would be 14 plus our key of 5, which is 19, also mod 26. So no loop was happening there. If we want to encrypt the message hi, we'll do it over here. We do it one at a time. Let's just do it over here. 1B. We have more space over here. Let's do it over here. So we can maybe lay it out a little bit like that. H and I. H would have the value 7. I has the value 8. So we could do it like that. Then we're encrypting here. Encrypt by adding our key 21 mod 26. Let's make this arrow longer. And 7 plus 21 is 28, which would be 2 mod 26. 8 plus 21 would be 29, which would be, well, they're right next to each other, so obviously 3 mod 26. And so this would lead us to look up what the 2 is. It's a C. And look up what the 3 is. It is, of course, a D. So this is our, what we call plain text, our original message. And this is what we call our crypto text, or our encrypted text. And so you would send the message CD, and only the receiver will know you're saying hi. That's nice. Not necessarily useful, but a nice message. So that's the idea. Now let's do the decryption, a decryption example. Let's put it over here. For the first one, we just have the letter E. That's our encrypted text. That we are now the receiver. We get the letter E. What was the original? So we have to decrypt that letter value that we got, that's 4, by subtracting the key, which would be -2 in our number line, but mod 26, that will be 2 less, so that will be 24, and we can look up what 24 is, and that is a y. Now, we don't have to think of it as modular arithmetic in this very, very simple situation. We're shifting by 6 places from E, 1, 2, 3, 4, 5, 6. But it lays the foundation, so y. Didn't we write the letter here? Well, we didn't write this letter that 19 corresponds to. Oh, I'm sorry. It is a T that we would send. It is a Y that the actual original message is. So yes, it is very simple, but by crossing over to this mod 26 idea, we're able to make the encryption rule fancier. Like we can multiply by a number, multiply X, and then add something. And that is already a step up in complexity. And it's much more difficult to figure out as an interceptor, to figure out what that message was. You now have multiple pieces to the key, and you can just go up in a complexity, and of course many steps of complexity. But our information security, what the browser is doing when you submit important information, all of it gets encrypted according to some encryption rule. Of course, they're much fancier, sure, but really it started with these very basic ideas. So that's kind of cool. Let's do a 2B over here. We have some space over here where we have A, L, and C as our cryptotext or encrypted text. That's what we are receiving. We're the receiver. So we now have to go backwards. First, let's see. Well, A is, of course, 0 because it's the first letter. And L was the next one. L is 11. C, well, C is, of course, 2. So this is the plain text value. Oh, sorry, not plain text. This is the encrypted text values. So we now have to, let's do it like this maybe. We now have to subtract our key of 4, and we have to do that mod 26. So then we will get 0 minus 4 mod 26 is 22. 11 minus 4 is 7. 2 minus 4 is -2, so 24 mod 26. And then this 22 will correspond to W. 7 will correspond to H. And 24 will correspond to Y. And then we understand our plain text message is the question why. So, of course, it is very good to do this by hand initially to get the idea and better understand it. You kind of have to do things by hand, slow things down, give yourself a chance to understand the ideas and the steps involved. But it's going to, of course, become quite tedious if we have an actual longer message that we want to either encrypt or decrypt. Of course, that could be a little bit tedious. So what I've done to streamline this, I wrote a little script in Scratch to demonstrate this, and it has nice colors in case you want to use it for kids as well. So let's have a look at that. It's over here, where it's just going to do the same thing we did by hand, but faster for many letters. So you have a little alien there, and the alien is going to encrypt our message. So let's just look at the message we want to send. Math is important. All right. So I'm going to press E to get this started. What is my plain text? Just to keep it simple, of course, you can introduce more symbols like a space symbol, uppercase and lowercase. Then your loop just gets bigger, your list just gets bigger. You don't have mod 26, you just have a larger mod circle. But the idea is all the same. Math is important. I will press enter. What is my key? Well, what is our key? Our key for math is important is 9. 9 is our key. Enter. And it's doing all the shifting for us, all the calculation. And that is the message that we can send. An interceptor reads that like, what? That makes no sense. But only the receiver with the right key, theoretically, knows what message we are sending. So it's just a way to streamline the same process when you have a lot of letters, and you can play with this if you want to. We can also, just for the sake of being complete, let's do a decryption. Now I have to type this in, don't I? That's going to be mildly annoying, but let's do it. Let's do it. I could probably copy and paste it, but that's okay. There's a little cat. I'm going to put in my encrypted text. CFIPYFIHAQYYEYHXM. Hopefully I did that right. Enter. That's my text. Now in this one, our encryption key is 20. Oops, get rid of that little top there. 20. No, 21. 20. Enter. And it'll do that subtraction systematically that we've done by hand. It just speeds it up. I love long weekends. Oh, now I understand the message. Amazing. So you can very easily incorporate some basic coding with this as well, and then make it more complicated by just making the encryption rule, and of course decryption rule, more complicated, that the interceptor has so many different key combinations and options that by the time they find the right one, your message doesn't have any meaning anymore. So it's a very nice application to see, because sometimes the mod circles and the arithmetic feels a little abstract, but it actually has an incredibly important application in our information security in real life. So there's some problems if you want to practice further that you can play with, but that is the end of our session for today. I hope you enjoyed it, and I will see you next time. Until then.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.